Good morning, students. We finished what is an acid, the properties of acids, uses of acids. Then we did bases and alkalis. We defined what is a base, what is an alkali, and we also studied what are the physical and chemical properties of bases, and then some important uses. Today, we are going to start with pH value of a medium. Now, before we start with that, what are indicators? Indicators are weak organic compounds which change color in accordance with the pH of the solution. Now, it means that indicators dissociate slightly in solution, producing ions and undissociated molecules. The color of the ions produced is dependent on the hydrogen ion concentration or pH of the medium. So if it is an acid, okay, when it ionizes, it produces H positive ion or hydronium ion. If it is a base, then it produces OH negative ion. Now we deal with pH value. What do you understand by the term pH value? pH stands for power of hydrogen ion concentration. Actually, if you want to calculate the pH value, we generally do it by using the formula pH equals to negative logarithm to the base 10 of hydrogen ion concentration. Okay, pH equals to negative logarithm to the base 10 of hydrogen ion concentration. Now, pH of a solution is defined as the negative logarithm to the base 10 of the hydrogen ion concentration expressed in moles per liter. Now, let us discuss what are the pH values. For instance, if the pH value equals to 7, then we say the solution is neutral. For instance, pure water. If the pH value is less than 7, let's say 6.3, let's say 2.1, then it is acidic in nature. If the pH value is more than 7, let's say 7.8 or 13, then it is basic in nature. Now, depending on the pH value of a solution, the indicators will change their color. For instance, if the pH value is less than 7, then you'll see that blue litmus solution turns red. If the pH value is greater than 7, let's say 12, 13, 14, then the litmus solution, red litmus solution, will turn blue. Again, if the solution is acidic in nature, that means the pH value is less than 7, then methyl orange, it changes to pink. Whereas if the pH value is greater than 7, maybe 8, 9, 10, 11, 12, 13, 14, then methyl orange changes to yellow. Phenolphthalein is a colorless solution. It does not change its color in an acidic medium, whereas phenolphthalein, which is colorless, it changes to pink in an alkaline solution. So these color changes brought about by certain indicators you should remember. Common acid-base indicators that we use in the lab mostly is litmus, methyl orange, phenolphthalein. These are some of the common acid-base indicators. Now, universal indicators, for example, universal indicators are mixtures of organic dyes or mixed indicators, for example, pH, paper, or solution. Generally, in the lab, we use litmus, whether it is litmus solution or litmus paper. Then methyl orange, and of course, phenolphthalein solution. Color changes, I've already mentioned you the color changes. Okay, for instance, if it is common acid base indicator, litmus solution, okay, what happens? If it is neutral, it will remain purple. If it is acidic, it turns to red. If it is alkaline, it turns blue. Methyl orange, if it is acidic in nature, then methyl orange changes to pink. If the solution is alkaline, then methyl orange changes to yellow. Phenolphthalein, which is colorless, it changes to color, it remains colorless in acidic medium but changes to pink in an alkaline medium. Next is universal indicators. The pH range, it varies from 0 to 14. So, if the pH value is less than 7, it is acidic in nature. If the pH value is greater than 7, it is alkaline in nature. Always remember, and very important to remember, if it is strongly acidic solution, then the pH value is minimum, maybe 1, maybe 1.23, or maybe 2. But if the pH value is, let's say, 5.6, then naturally it is weakly acidic in nature. But on the other side, if the pH value increases drastically, let's say 12, 13, 14, then it is strongly alkaline. But if it remains somewhere around 8, 9, then it is weakly alkaline. Now, the pH value finds its use in agriculture, dairies, technology, and medicine. For instance, you fall sick, you go to a pathologist, okay. So the pathologist checks the urine or blood, okay, for diagnostic purposes. Similarly, a change in pH value of milk, okay, it indicates the milk has turned sour. It finds use in agriculture to test the pH of a soil for better growth of crops. Now, acidic solutions, for instance, dilute hydrochloric acid, it has a very low pH value, followed by sulfuric acid 1.2, acetic acid, which is an organic acid, 2.9, tartaric acid found in grapes, which is 3.5, lactic acid found in milk, which is 6.6. So as the pH value rises, you see it is it becomes less and less acidic in nature. Whereas alkaline solution, as the pH value increases, it is strongly alkaline. For instance, human blood has got 7.3, whereas the pH value of sodium hydroxide is 13. That means it's a very strong alkali. So there is a vast difference, okay? So as the pH value increases, naturally the solution or the medium is highly alkaline. As the pH value keeps on decreasing, and when the pH value is minimum, then you can say the solution or the medium is strongly acidic. With this, we come to the end of today's lesson. Please learn the pH values, etc., and also learn the important definitions. Thank you.